related stuff. So predominantly, I mean, like in Panda and as Zetwork as well. So you can see that like all the projects that we're working on, so all of these independent like microservices that we're working on, so they're all of them are like containerized and they're deployed using like tools like Docker or Kubernetes, all of these things. And there are some standalone projects as well, like apart from these projects being containerized. Like for example, like one standalone project that I was working with was like this was like a small starter sort of a package where we built a library where like the problem statement was like initially we were finding it a little difficult, like when you onboard new people into your team. So it was a little difficult for them to go through the entire setup. It used to take 2-3 days for them to make the entire setup and download the data, like put it in a dump and all of those things. So like now we've just written a simple script that runs on top of Docker. So you just need to run that particular script using basically that will do the entire the setup, the initial setup and everything that you need, like being it downloading the data, like downloading your code from GitHub, like like downloading your dumps from Jenkins and then installing it on your local. So all of these things is done in like a matter of a few seconds, right? So that is the sort of change that it can.
By the way, quick check, everyone. How many of you often have faced yourself being stuck in just setting up your environment? For example, let us say you are working upon a software engineering project. I mean, how to write the code, how to fix a particular bug, but setting the project itself becomes a problem. You have to install a database, you have to install a cache. Do a thumbs up if you have ever faced this kind of issue. So many of you have faced this issue.
Yeah. I mean, and the fact that, how many ever times you do it, it's always like you are doing it for the first time because you will still end up with some issues or the others. So,
right. I mean, it's very interesting. I mean, it's one of probably the easiest things, installing MySQL, right? So when it's clearer classes, we teach MySQL. There are a good number of learners that get stuck even in getting MySQL installed. Why? Because sometimes the operating system is not matching. Sometimes the architecture of the machine is different. All of those kind of things. Okay. So, but actually, I have a question for you. You are currently working as a full stack developer. As far as I know, your official title is like a senior software engineer. As well as you have been involved in DevOps or data related work, right? Many learners in this particular session are probably going to be from both the domains. Quick check for all of you. If you are currently a software engineer or one of these, data engineer, ML engineer, if you're into a software role, software engineer, backend engineer, full stack engineer, front-end engineer, data engineer, do a thumbs up. Or if you are into a DevOps related roles, DevOps engineer, cloud engineer, SRE, a cloud architect, do a thumbs down. Can you all do a thumbs up or a thumbs down depending upon if you are from a software engineering side or if you are from DevOps side? Good. So we kind of, as it appears, we kind of have a 60-40 or 70%, right? It seems like 60-40 split. 60% of the people are from software background, 40% of the people are from the DevOps background. So, Brahmi, what is kind of the difference between these two roles? What is the difference between SDE and DevOps role that you have seen probably in your past experience?
Right. I think so. As a software engineer, you need to be having like very strong programming skills. You need to be proficient in one or more programming languages on a particular tech stack or a framework. So you are responsible for delivering the project, like right from like the requirement phase, like building architecture and then like putting it into the form of a code, deploying all of these things. But I think as a DevOps engineer, things are a little different because you need to have that understanding of how the infrastructure is built up. So it is not that you are like solely tied up to a single project, but you need to have an idea of the overall organization's infrastructure and how the networking happens. You need to be proficient, of course, in some tools, like it can be either a Docker or a Kubernetes or Terraform or Jenkins, and probably like a very strong understanding on a CI/CD pipeline as well. Right. So I think you need to have a collective understanding of a lot of these things as well as a DevOps.
So I think one thing that I had hidden from all of you is that Abhirami, you also have been a Scalar alumni, right?
Right.
With Scalar, you did a bit works and then currently you are at Panda Hill, right? So how did you start your upskilling journey with Scalar? What was the introduction point of that? Was it also a masterclass like the one many learners are attending here?
Right.
How has your feedback overall been with respect to Scalar? Any advice that you may want to give to the learners who are attending this session?
Right. I mean, so that is going to be a little different because again, when I got started, most of these jargons that I'm using now, like, I haven't even heard of them before. Like, for example, I didn't even know what was system design, right? I didn't know what was a CI/CD pipeline. I didn't know like most of these things. Like AWS, I knew existed, but I didn't know most of the, services being provided by AWS. So I was you can see movies. I mean, like, because again, like in Infosys, I mean, like, I was trained in Oracle, like personally, and like, so didn't have much hands-on working on any particular like development or DevOps or anything for that matter, because I was predominantly working on the support sort of a role, so didn't have much hands-on experience working on projects or anything. So I think that is where I started, but always wanted to get into like a very like specific, wanted to specialize on any particular domain. So I think that is where my thirst for learning started, but I started very differently. I started with self-learning. I did self-learning for nearly 2 years, but again, these terminologies I was not able to grasp them when I was doing self-learning. So that is when I sort of sought some professional help, and then like luckily I landed up with Scalar, because one of my friends was already doing a course with Scalar. So it was like a 1 year long journey, but I think like 5-6 months down the line is when I got my offer with Zetwork, and then that was, I think, the turning point in my professional career, basically, because I think the learning from Scalar, and then in the second half the learning that I got from Zetwork was also immense. That when I moved into this company, it was more of a cakewalk. So I think that's pretty much how my transition has been. So yeah.
Got it. So Abhirami, I think I'm glad to see you had a very great journey with Scalar. I think you are doing great in your career. You had and definitely hold a very good future ahead. Thanks for taking out time today to motivate all of the learners to learn Docker, Kubernetes, to upskill themselves, to probably learn these things, because they are going to be helpful for them in their day-to-day career. I mean, can't highlight that much. Thanks, Abhirami. Thanks for taking out time.
Thank you so much for having on. I think all the best to you with that. Have a great session. Yeah.
Sure.
Awesome. Cool. Said, Abhirami. So on that note, guys, just like you understood the entire journey of everyone all together, we have got another profile, that is Bhaskar Shaw. He was someone working in Accenture as a full stack engineer. Post Scalar is working as an SD when it comes to Walmart. Now, guys, I was getting a lot of DMs wherein people want to connect with Abhirami or similarly Bhaskar in a one-on-one format. So let me just help you in that manner here. So I will just quickly launch a poll here. So if you have any questions that you want to ask Abhirami, or it might be Bhaskar as well, you can just click on yes onto this poll and click on the submit button. Again, guys, this is not a sales call, and the best part is that you can directly connect with Abhirami or similarly Bhaskar in a one-on-one format. And the best part is that there is no mediator in between you or the alumni here. So the Scalar is not even coming into the picture. So you can just conversate with them in a Zoom link, you can just connect with them in Google Meet, whatever suits you. But in the meanwhile, what you can do is that you can just note down all your questions that you want to ask Abhirami or Bhaskar regarding your career part, how to vanquish your career gap, how to get into such amazing roles altogether. So for all those set of questions, just click on yes onto this poll and click on submit button as well, so that your response is being recorded, and shortly we will connect with you regarding the same. So again, getting the fact, being a completely free of cost service, would definitely recommend you everyone clicking on yes onto this poll and click on submit button, because that would be very beneficial to get a personalized career roadmap from someone who is doing such well in terms of their career ahead, right? So you might not know, you are one click away from getting into such brilliant roles and whatnot. So don't miss out on this free of cost opportunity altogether. All right, so as the poll is running, let me also share the WhatsApp group link wherein Abhirami and Bhaskar is waiting for you connecting the one-on-one format. And last but not the least, let me also share the LinkedIn profile of Abhirami, as some of you were also inquiring for the same. So yeah, I believe you'll be bombarded with requests coming to Abhirami in just a few seconds, but yes.
Sure.
Thank you so much for joining in.
Thank you so much.
Over to you, Naman. You can just take it forward.
Sure. Cool. Let me share my screen. Perfect. Is my screen visible? Yep, super. Cool. So now let me start with the very first agenda item. As I had shared earlier, we're going to start by talking about Docker. For the very first half, we'll be talking about Docker. After completing Docker, we'll be starting to talk about Kubernetes. Right? Now, one problem that I typically see a lot, specifically in the people who are coming from the DevOps background, is that a lot of these people are tool focused. Okay, so for example, a lot many people in DevOps domains come to me that, okay, sir, will you teach Jenkins? Will you teach Ansible? Will you teach Docker? Will you teach Kubernetes? Will you teach AWS Elastic Beanstalk? Those kind of things. Rather than focusing on foundations, rather than focusing on why behind the concept, they're completely just focusing on learning a lot of tools. Okay. Now, while that might sound cool, while that might sound that you know a lot about different technologies, But the thing is, that is not what the best companies look out for. That is not what the best DevOps engineers stand out for. That is not what the best companies want to hire for. For example, let me just take a very simple analogy. Let us say if your car breaks, let us say there is any issue in the car, where do you go? Whenever you have any issue in a car, where do you go? Whenever you have any issue in a car, where do you go? You go to a mechanic, right? Or do you go to a screwdriver engineer? Do you go to a hammer engineer? Do you go to a spanner engineer? No, you go to a mechanic. Now, who is a mechanic? A mechanic is someone who knows the problem statement and knows what is the best way to fix that particular problem statement, right? They know the problem statement. They know that, okay, car has broken. They will fix that. They will figure out why the car has broken. Then they will figure out what is the best tool to solve that particular problem, and then they will solve that particular problem. Similar is what is the expectation from a good software engineer as well as a good DevOps engineer. You should not just be a tool specific person. You should not become someone like a Java developer, a Python developer, a Docker engineer, a Kubernetes engineer. You have to become a software engineer, or you have to become a DevOps engineer or a site reliability engineer. The difference between these two is you're not just focusing upon a specific tool. You're not just someone who knows a lot of syntactical details about a tool and how to use that. You know why even a tool is needed. What is the problem statement that tool solves? What are the different alternatives that can be there? What are the pros and cons of each alternative? And this is what differentiates from a good engineer to a great engineer. And that is why please don't end up becoming a screwdriver engineer. Please try to become a mechanic. So what I'm going to do is, in today's session as well, I'm not going to just go on different syntactical details about Docker. We're going to start with why do you even need that? What is the problem statement that is underneath? And then how Docker will solve that. Similarly, we'll do that for Kubernetes. Okay. Now to understand the problem statement behind Docker, let us try to understand the journey of a software engineering project. Okay. Journey of a software engineer project. Cool. Okay. Now, in a software engineering project, what is the core of a software? I mean, what is the core of a software? What at the end is happening when a software is there? What at the end is software? It's code. At the end, software is nothing but code. Perfect. So in any software engineering project, there is going to be a code that is going to be written by a software engineer or a back-end developer or a front-end developer, all of those kind of people, they will write the code. Okay. Now, after the code has been written, what will happen to that particular code? After the code has been written, what will happen to that particular code? That code has to go to the users. Users have to be able to see that particular code. The code has to be visible to them. Okay, till the time the code has just been written, it is just present on the machine of the developer. It is just present on the machine of the engineer. Now, this code has to go to production on the servers. Okay. Perfect. Now, the journey from this code on the machine of developer, okay, to the production servers is going to be very interesting. Okay, see, let's talk about a company like Google. How many times every day do you think Google engineers will make changes in their code? How many times a day does a Google make changes in their code? Does a Google add a new feature? Does a Google solve a particular bug? People are saying zero. Okay, interestingly, Google has 10,000 plus changes per day. Changes per day. While you might not see a change, behind the scenes there are tens of thousands of changes that are happening every day. Right? There are small bugs, there are small nitty-gritties that are being solved every day. Okay, now imagine, whenever these changes are being done, whenever a code is being changed, let us say it takes one day for that code to go live to people. Do you think that developer will be happy? The developer, the engineer who is working upon that particular feature, will they be happy? They will definitely not be happy, right? When your code has been worked upon, I'm showing blank screen. Parmeshwar, please refresh your browser. As soon as you will refresh your browser, things will work perfectly fine. Okay, cool. Now, as soon as the code is changed, as soon as the code is ready, ideally an engineer would want that particular code to go live immediately, within a few seconds, right? Similarly, if you have to do tens of thousands of changes per day, if you had to do a lot of manual work for that, right? If you had to first maybe let us say first create a new server, now on that server install an operating system, on that particular operating system download the code of the application, then you had to do a lot of work. Do you think developers will find it happy, or do you think the engineers will find that as a good lucrative job? The answer is no. So ideally we would also want the code to go live immediately, as well as we would want the things to be as automatic as possible. Right? As automatic as possible. Perfect. Cool. Shikhar, yes, I mean, I'm assuming that whenever the code is written, after that the code is tested as well. So that is what I'm assuming as well. Okay, super. Now, the code has been written. After the code has been written, ideally we would want the code to go live to the people so that we can see if the feature is working well, if the users are liking that particular thing, if the people are having a great experience. We would want that to happen as soon as possible in an automatic way, so that our changes are going live very immediately. Chandan is saying, why? Chandan, if every day, let us say you have to do one work repetitively, will you feel happy? If every day you have to do the same thing again and again, will you be feeling happy? The answer is no. That is why you automate the things, so that you are not bored, so that you can focus your time on things that are more interesting to you. Perfect. So what happens is, code is written. Okay, after the code is written, code is gone live to production. Okay. In an automatic way. Now, is the work done? Is 10,000 changes really happen in a single day? Yes, Harshita, Google is not just that Google search. Google has hundreds of different things. Google has Google Chrome, Google has Android, Google has Gmail, Google has, I think, Google Plus. So there are a lot of things that Google has, right? Google is not a small company. Okay, so cool. Yeah. Now, what happens is, when the code is live, when the code is in production, there will be a lot of nuances. There will be a lot of problem statements that will happen. There might be a bug that might be there. There might be something that might break. Now, whenever that particular thing will happen, whenever something will break, ideally we would want someone to monitor that. Right? For example, very recently, how many of you know that Instagram went down? How many of you know that very recently Instagram went down? Right? Very recently Instagram had gone down. I think even Facebook went down. All of those had gone down. Okay, perfect. Now, you need someone. Correct. When Mark Zuckerberg was at Ambani's wedding, at that particular time, Instagram has gone down. Absolutely. All of you know the correct things. Okay. Anyways, now what happens is, when the code is live on production, okay, there is need of someone to monitor that particular code. Someone is needed to monitor that particular stuff to ensure things are working smoothly. Ensure things work smoothly. Perfect. Now, based upon that, if you find a bug, if you find an issue, then what you will do is you will again make changes in your code, so on and so forth. Perfect. Now, let us focus upon this particular part. Code and code going live to production. Okay. Let us say we are in 1990s. Okay. Let us say we are in 1990s. We are in very old days of a computer. Okay. So, we have to run a code on production. At the end, what is a production? At the end, what is a production environment? A production is nothing but a At the end, production is nothing but a computer. Absolutely correct. When you have a code and you want that code to go live to production, production is nothing but a computer. Right? It is nothing but a computer on which you want to run an application. Okay. Super. Now let us focus upon this particular journey. A code is there and you want to run that particular code on the computer. Okay. Till now, when you have to run a code on a computer, what are the different steps that you have to do? For example, let us say a code has been written in Java and you have to run that particular Java code into your machine. What all will you need to do? What all will you need to do? I mean, will I just install Java and will it work? Will I just install Java and will it work? Is that all? Well, not really. Let us try to think of this. Okay, so on my computer, let us say this Java code was written on your friend's computer. Okay, was written on computer of your friend. Okay, and now you are running on your computer. And let us assume that your machine is completely new. Your machine is completely new. Okay. Perfect. So your friend has given you a Java code. You have a completely new machine. Nothing is installed there. Nothing is there. Okay. Now you have to run this particular Java code. What will you do? Probably you will first try to run it directly. For example, you will see that, oh, there is a .java file. You will see the code, oh, there is a .java file. So let me install Java. Okay. After installing Java, you will try to run. What is the probability that it will run on the first try? After installing Java, you will try to run. What is the probability that it will run on the first try? The answer is very less. There is a let us say there is just a 1% probability that it will run. 1% probability that it will run. Okay? Why only 1% probability that it will run? Whenever you write a code, is a code completely independent? Whenever you write code, is code completely independent? Is the code only your own code, nothing else, no third-party dependency? The answer is no. Typically, whenever we write code, our code often depends on third-party dependencies. Our code often depends on third-party dependencies. Okay, for example, in your code, let us say you have written a code in Java and you want to talk to database. What will you need? Which dependency will you need? If you have written a code in Java and if you want to talk to a database, maybe you want to run a query in a database, which dependency do you need? Absolutely correct. If in your Java application, you want to talk to the database, you need dependencies like JPA. You need the dependency of JDBC. You need the dependency of MySQL or whatever database you have, right? If you're using MySQL database, you will need to have the dependency of MySQL. You will need to get all of these dependencies installed. What are dependencies? A dependency is nothing but a code written by someone else. Code written by someone else that we use, that we make use of to reduce our work. Okay? Perfect. Cool. Dasari, you don't need to know anything about Java. Okay? But a very common sense thing is that whenever you will be writing code, you will not be writing everything yourself. In fact, there is a rule in software engineering, there is a rule in tech. Stand on the shoulders of giants. Stand on the shoulders of giants. Okay? What does this particular rule mean? And another word, this rule means don't reinvent the wheel. Reinvent the wheel. In even simpler terms, this means reuse wherever possible. Reuse things wherever possible. Okay. So this rule says that whenever a code has already been written, okay, if someone else has already done some work, rather than redoing the whole code, rather than writing your code completely yourself to do the same thing, try to use the work that others have done. Why? For example, let us say today, someone has written a code on how to make a database connection secure, or how to have cryptography, or how to have security in talking to database. Do you think you will yourself be able to write as secure code as someone with probably 15 plus years of experience would have already written? The answer is probably no. The person who would have written the code with 15 plus years of experience, it will not be easy for you to match that. There will be hundreds of nuances that person will know that you will not know about, right? That you will not be aware about. So it is always better to reuse the code rather than to reinvent the wheel. So what happens is, almost always, whenever we are writing any application, we also depend upon third-party dependencies. We also depend upon third-party codes. How many of you agree with that? How many of you say that that particular thing makes sense? Perfect. Now what happens is that in this particular case, when we try to install the Java application, so what did I do? I installed Java and I tried to run the application. Why might the application fail? The application might fail because of a bug. Oh, dependency is not found. Dependency is not found. Okay, your code was dependent upon some particular dependency and that dependency was not present on this particular new machine. Now you are failed. Now you are not able to get the things done. Now you are having an issue. Perfect. Now how will you try to solve this? So one way to solve that is one by one. One way to solve that. Yes, Ankit, we will be doing practical, don't worry. Okay. One way to solve that is one by one. Whenever you see error, for example, the error is JDBC not found, MySQL not found, you will try to install JDBC, you will try to install MySQL. One by one till the time all the errors are gone, you will try to fix them. Okay. What are the other issues that can happen? Other issues that can happen is, for example, that let us say your Java application. Okay. Your Java application was depending upon a particular file. Within your code, you were reading a file at particular location. For example, you were reading a file at C home desktop abc.pdf. Okay, you were reading this particular file. This file, that means, would have been present on the machine of who? Who wrote this particular code? This code was written by the developer. That means on the developer's machine, this file was found. Does that mean that in home desktop abc.pdf, on the machine of you where you're trying to run this application, does it mean that there also abc.pdf will be present? There is no. There may be some nuances. There may be some things that may not be present even in your machine. For example, a file dependency is not present. File dependency not present. Okay. Now what will you try to do? You will again try to go to your friend. That, hey, it is asking about this file. Do you have this particular file with you? Okay. The friend gave that particular file to you. Now you come back home. After you come back home, then you see an issue. The next issue that comes up is that this application is written for Java 21 and you have Java 17 with you. How many of you have seen this kind of issue? That typically when you try to install a software, or let's say when you try to install an Android application, the application fails because it says that this application needs Android 5, this application needs Android 12, or this application only works on Windows 8 or above, this application only works on Windows 13 or above, this application only needs iOS 17 also. Then the thing is OS or platform incompatibility. Okay, cool. One last thing. Another last thing can also happen is often computer architecture. Okay, I'm not sure who is trying to call me again and again, even when I'm on Do Not Disturb. Okay. The last thing is computer architecture. Now, what exactly is a computer architecture? Okay, how many of you, when you try to install a software, you have seen something like x86 or AMD 64? How many of you have seen this? Right, two types of architecture you see. Do you want to install it for x86 or earlier? For people who are probably old enough, how many of you have seen when installing a software, do you want for a 32-bit or 64-bit? How many of you remember this? For Windows, whenever you try to install an application, do you need a 32-bit or do you need a 64-bit? But those things are. That also is the operating system architecture. An application that is written for a 64-bit computer may not work well with a 32-bit computer. Similarly, an application that is written for a 32-bit computer may not work well for a 64-bit computer. That means to do even one simple thing, to run even a simple Java application, what all did you do? What were the prerequisites? The prerequisites were correct machine. Okay. After correct machine, you needed to have the correct operating system. After the correct operating system, you needed to have the correct platform. After having the correct platform, you needed to have the correct dependencies. Okay. You needed to have correct dependencies like other code, any other file that you are dependent upon. Okay. And after that, finally, you needed to have your code. If any of them is not available, your application will not run perfectly fine. What is platform? By platform, I mean correct version of Java, correct Java version, etc. Okay. Perfect. Java is operating system independent, but the code inside it might not be operating system independent. Okay, there might be problems there. Okay, so good. Now let me ask you a question. Cool. Now let me ask you a question. Do you think if all of these are correct, if all of these are perfectly same, are we ready? Do you think then there will be no problem when you run this application? Can you tell me what also can go wrong? What also can go wrong? Anything specific that you see wrong. Now you are trying to run this application on another computer. What can go wrong on that particular computer? Think better, think better. Okay, tell me one thing. In one particular computer, is there only one application that is going to run? Do you think in one computer only one application will be running? The answer is no. There might be multiple applications that might be running. There might be another application. There might be an application 1 that is also running on this computer. There is an application 2 that is also running on this computer. Okay. Now let us say you have your application 3. This application that you are writing is application 3. Okay. Now this application 3 wants to run upon a particular port. Let us say 8080. Okay, so what does this application want? This application wants to request or wants to receive data on port 8080. Okay, if any of these applications is already running on port 8080, do you think this application 3 will be able to run on port 8080? The answer is no. If any of these applications are already running on port 8080, the operating system will deny this. OS will deny this. Acha, and if this application was not there, if application 1 was not there, will application 3 be able to run? The answer is yes. Okay, because operating system only allows one port to one application. Prashi, because operating system only allows one port to one application. Okay? Because of that, if one application was already running on port 8080, another application will not be able to run on port 8080 because there is a conflict. Someone else is already running on port 8080. Okay, that is fine. Clear? Okay. Now that means another thing that we also have to be careful of. Other applications running on the machine. Okay. Basically, keep your applications isolated. Because of someone else also who is running on the same computer, there also can be problem. Okay, cool. So 8080 and 3000 are same. Shithil, what do you think? Just by reading the message that you have sent, what do you think? Are 8080 and 3000 same? No, right? Obviously, no. They are different ports. They are different flat numbers. They are different house numbers. Okay, they are obviously different. Okay, so cool. Now that means when we are running an application, to run an application is not going to be a simple thing. You will have to ensure that dependencies are there. You will have to ensure that the conflicts with other things that are running are avoided. A lot of prerequisites have to happen. Now imagine what happens is typically the code is written by software engineers. Okay, software engineer has written code. Perfect. Now after that, to get this code live, just give me a moment. Cool. Super. Cool. Now, this software engineer has written the code. Do you remember that after this code has been written, get this code live to servers? Who does this particular work? Typically, this particular work of getting the code live to the servers as soon as possible is handled by who? Who handles their monitoring these servers? Correct. This is where DevOps engineers come into the picture. DevOps or cloud engineer or SREs, depending upon whatever is the role called at your company. Coders write the code. After that, what do? They get the code deployed and monitored. Perfect. Now imagine that if one application has been written, to run this application on the servers, this work was manual. A DevOps engineer, a person, had to manually create a new server. On that new server, they had to first ensure that there was the correct machine. Then they had to ensure that the operating system was correctly installed. Then they had to choose the platform. They had to install the correct version of Java. After installing the correct version of Java, they had to install the correct dependencies, maybe install the correct version of everything. For example, let us say your application needs Razorpay version 17. Okay, Razorpay version 17. Your application needs MySQL version 8. Your application needs JUnit version 5, whatever. Ensuring that all of this thing is installed, all of this had to be done manually. Would DevOps engineer love their job? If the DevOps engineer's job was to manually go to each server, now on each of this server, do all of this particular thing. Choose, first of all, the machine is correct so that your code runs perfectly fine. After that, choose the correct operating system. Then choose the correct platform. Then install those dependencies one by one manually. Then get the code downloaded. Then do all of that. Do you think DevOps engineer would love their job in this particular case? Would DevOps engineer love this code? The answer is no. Now think of this. In reality, do you think the code is running on only one machine? For example, right now in this particular scalar session, is the code running in only one machine? The answer is no. Code is not running on only one machine. Code is running as of this moment probably because there are like 5,000 people who are probably attending Scalar at this particular time. The code might be running on over 100 plus machines. If the code is running on over 100 plus machines, imagine whenever a software engineer makes a change, one DevOps person has to manually create 100 plus machines. On each of those machines, install the correct operating system. Then after that, on each of those machines, if there is any file that is there, if there is any dependency that is there, manually do all of that. Then manually download the code, then do all of that work. Do you think DevOps engineers are going to love their job? The answer is obviously no. DevOps engineers will hate this particular job. Okay, DevOps engineers are definitely going to say, this is not the work that I'm going to do. This is a very tedious work. This is a very operational work, so as to say. So ideally, we need automation. We need automation. But other than automation, we also need to ensure that all dependencies as per how the developer wanted it are present. Okay, let me actually ask you a question. How many of you during your university days, during your school days, often built a project which was working perfectly fine at your home, but when you presented it to someone, when you were presenting it to a school teacher or your university professor, it stopped working? How many of you have had this kind of scenario? It was working perfectly fine at home. At home, it was working perfectly fine, but when you were trying to present it, it failed. Now, that is what we have to avoid as much as possible, right? It would have been a very big problem. Right? It would have been a very big problem if the code that a Google engineer has written, it's working perfectly fine on their machine, but as soon as the code goes to production, Google is breaking for everyone. That would have been very surprising thing. That would have been very bad thing. So we would want to ensure that all of the dependencies, etc., are as per exactly how the developer wanted to be. Then only the life will be better. Then only we can trust the code. Then only a software engineer can trust that if they do tens of thousands plus changes every little day, first of all, those changes will go live to production, as well as nothing will break, as well as no surprises will happen. Nothing like this will happen that, oh, this thing was present on my machine, but this thing is not present there. How many of you agree with the need of both of those things? How many of you agree with that? Perfectly fine. Cool. Now, let us try to solve this particular thing. Okay, cool. Achha, by the way, before we solve this thing, I'm actually also getting some questions about scalar, etc. as well. Let me actually talk about one thing, right? Sir, Hindi mein samjha, Ujjwal, no. I mean, while you might only know Hindi, believe me, two things. In your day-to-day job, Hindi is not going to help you. I mean, while we do communicate in Hindi, but any official communication, etc., will be happening in English. So please please do get basic proficiency in English as well. No one is asking you to become René and Martin, okay? But please do expect basic communication skills. Otherwise, you are destroying your career, okay? Cool. Perfect? Super. Now, one just thing, many of you are also asking that how do we cover all of these things? And I will talk about how we cover these things at Scalar after like 40-50 minutes or so. But what I wanted to do is to avoid all of the Scalar questions right now. Swan, can you please just do one thing? Can you just run a poll in the chat? Okay. If anyone has any questions with respect to Scalar, if you want to know, do we cover these in the Scalar's DevOps program? Do we cover these in the program of Scalar SRE at there? Do we cover Docker? Do we cover Kubernetes? What is Docker certification? What is Kubernetes certification? All of those kind of questions that you have, please feel free to just say a yes in the chat. While I will talk about them briefly a bit later, just for now to avoid all of the questions in Scalar, just say a thumbs up, just do a yes in the poll that is currently running on the screen, and after that, let us focus on what we are learning. Okay? Later we'll talk about that. Okay? Nitya, we will be having a break around 9 when I will talk about scalar in more details. Okay? So everyone, just say a yes in the chat in case you have any questions with respect to scalar. In case you have any questions on how we cover these things in the scalar curriculum, how much in depth we cover Docker. By the way, to give you an idea, while we cover Docker and Kubernetes in 3 hours in this session, in the scalar curriculum we cover it in I think 4 weeks. So that is how depth we cover. Okay. Anyways, we'll get to that a bit later. Let me reshare my screen. Perfect. Is my screen visible now? Is my screen visible with all of you? Super, cool. Now, let us try to do this. Let us try to build something like this. Okay, something that is automated and something that is needed to ensure that all dependencies are exactly as per how the developer wanted it. Okay, cool. For now, let us remove the requirement of automatic. If there was no requirement of automatic, how would you ensure that all of the servers, all of the machines on which the code is running is exactly same? How will you try to do that? If there was no requirement of automatic. Checklist, Pawan is absolutely in the correct direction. If there was no requirement of automatic, if instead of automating something via a machine, there were manual humans, what will you do? You will create something like a checklist for humans, right? If we did not need automation, if we didn't need automation, maybe what we could have done is we could have created a documentation. We could have created documentation or a checklist that has to be followed by every person. That has to be followed by the person who is going to do the work to get code live on production. Right? Maybe I would have created a series of steps. For example, steps could have been something like this. Step 1. Okay, maybe go to aws.com. After going to aws.com and get a machine, okay, of XYZ type. Very specific set of instructions. Yes or no? Would you do something like this? Okay. Do you recommend? Absolutely correct. Then in step 2, what will you do? You will probably say, okay, on the machine, run this command. On machine, run this command. Okay. After that, step 3, run this command. Everything will be there, right? Run this command, download this file. All of these commands will be written specifically there, and a manual person would have to follow this. Do you agree? And if there was no automation, then a manual person would have the work to follow a documentation or follow a checklist. Now, what is the problem with this approach? What is the problem with this approach? The problem with this approach is this is very, very slow. Very, very, very slow. Right? As well as this is prone to errors. Many people forget instructions. Many people forget to follow the things. Okay. Many people miss out things. Okay. They may just forget a command or they may execute a wrong command. They might make human errors. They might make human mistakes. And that can lead to a lot of problems. That can lead to a lot of issues. Okay. So it's time consuming. It is prone to errors. It is not easily trustable. You can't easily trust that. Perfect. This is where we get the first topic. What is the very first topic of today's class? What is the very first thing that we were learning today? The very first thing that we were learning today was Docker. Okay, this is where Docker comes into the picture. What is Docker at the end? At the end, you can think of Docker as just solving one problem statement. Docker is solving the problem statement to ensure that the application, is running exactly how a developer wanted it to be across every machine, as well as, more importantly, in an isolated way. Okay, so Docker is solving two problem statements. What are the two problem statements that Docker is solving? First of all, Docker is providing isolation. What does the word isolation mean? Isolation means independent. There should not be conflict that is coming because of other applications that are running. Okay, avoid conflicts coming from other applications that may be running on same machine as well. Okay, machine as well. As well as the second problem statement. The second problem statement that Docker is ensuring is it is solving the problem statement of consistent environment. Anyone, any guesses what do you think the word consistent environment means? So Shakil, I will get to that. Okay, I will get to that, how it does that. Okay. Consistent environment means regardless of where you are running, all of the dependencies, prerequisites, etc. are present. Prerequisites, etc. are present. Okay, so everything is present how a developer wanted it to be. Now, the problem statement that gets solved by that is, now, along with this, Docker is also providing you automation. For this particular thing. So now you don't have to do manually. Once you write a script, once you write a configuration, and then Docker is going to automatically manage this. Now, if all of these things are done, if there is a tool, if there is a software that is allowing you to have an isolated, consistent environment in an automatic way without requiring any manual intervention, is the problem statement of the DevOps engineer solved. Now, do they need to manually go to tens of thousands of servers? Whenever any code change is done, they have to manually go follow a series of instructions and run the code. Now they don't have to do any of this thing. Now their work is automated. Now their headache is reduced. Now the chances of error are reduced. This is what Docker is. To understand Docker in a simpler way, there is another very popular meme, okay, which is this one, I think. I think all of you would have seen this, but this meme will kind of explain to you what Docker does in a bit simpler terms. Just a moment. I'm trying to find that out. I think it is this one. Yes. I'm getting there. Okay. This is the problem statement that Docker solves. What Docker does is, Docker avoids these kind of problems. The problem is that where a developer says that the code was working perfectly fine on my machine, but for some reason it is not working fine on the production machine. Docker will reduce all of those things. Why will Docker remove all of those things? Because Docker is ensuring that when your application will run across any machine, now if you try to run the application across any machine, Docker will ensure that the environment is same. That environment is exactly how the environment was there on the developer's machine. All of the dependencies are there, the exactly same operating system are there, the exactly same prerequisites are there. If there needs to be a file present in a particular place, the file is also there. Docker is going to ensure that the environment is as exactly same as it was there on the developer's machine. It is going to solve all of the prerequisites. It is going to get all of the dependencies, all of that in an automatic way. As well as Docker is going to ensure that no other application that is running on the same machine interferes with your application. Okay, if your application needs support, your application will get support. How does Docker do that? I will get to that. But is the problem statement that Docker solves, or what at the high level Docker provides, is that clear with everyone? Is that particular thing clear with everyone? Super, cool. Now, let us try to get to how Docker does all of that work, how Docker tries to solve all of this. Super. Now, if there was no Docker, then how would it have been solved? If there was no Docker, then what was there? What was the alternative of Docker? Without Docker, without any automation, how were people trying to ensure that the environment across different machines was same? Via a manual series of steps, correct? So before Docker, there was a manual set of instructions. There were instructions that were written, there were instructions that were documented that a manual person had to follow to be able to run the commands. Now, what happens after Docker? Now, in Docker as well, you have to write instructions. But those instructions are not like English statements that have to be followed by a person, but those instructions are like a configuration file. After Docker, there is something called Docker file. What is a Docker file? A Docker file is nothing but a configuration. Okay, which specifies, it's kind of a code which specifies how exactly your environment should look like. Okay, for example, in this particular thing, in this particular config, in this particular code, you will say that, okay, I need this operating system. Okay, I need these files. These files should be at this particular location. I need to run these commands, but this is the command 1 that has to be run. This is the command 2 has to be run. So what do? You give a configuration. Okay, and this configuration is like a code. Now, if this configuration is like a code, now can it be automated? Now can anywhere, wherever you give this config file, will the exact same environment be set? Absolutely correct. So what you do is, in Docker, also you have a documentation. But the documentation that you had earlier, that documentation was followed by whom? Who followed this documentation that used to be there before Docker? Who used to follow this particular documentation? This used to be followed manually by DevOps people. Okay. But what happens after Docker? Now this config that you have written, this config can be read by Docker engine. And what will this Docker engine do? Docker engine will read this config file. Docker engine will read this set of configuration. That do this, do that, and set up the environment. Now, because this config can be read by an application, by a code, all of this will be automatic. Is everyone clear with the benefit that Docker provides? We have understood what is Docker, the benefit that Docker provides, the problem statement that Docker solves, as well as what Docker file is. Docker file is nothing but a series of steps that are followed by Docker engine. Okay, I will just repeat that. Don't worry. I will just repeat that. Okay, I will repeat that after a few minutes. Just give me 5 minutes. Array, I will show you the code of this as well. Don't worry. Nothing to worry. Okay. Perfect. Now let us see what actually happens. See, now this application that you are writing, this application at the end will be running upon a particular computer. Absolutely correct. This application at the end will be running upon a particular computer. Yes or no? At the end, any application that you will be writing has to be written upon a particular computer. Cool. Now earlier what used to happen? Okay. So let us say earlier. Now this is after Docker. Okay. Earlier there was manual documentation. Now what has been replaced by manual documentation? Instead of documenting the series of steps in English that a person has to follow, you have something called Docker file. Where you just write the things. But now another interesting thing was there. Earlier, what used to happen was you had a computer. Okay, on this particular computer, you had an application. And this application at the end runs on operating system. Do you agree that whenever you run any application on your computer, that application is running on the operating system of your computer? Do you all agree to this particular statement? Absolutely correct. So this application was there. This application was running on the operating system of the computer. Super. Now what happens with Docker? Now with Docker, because Docker is actually automating the work, right? Docker is the thing that is automating the work. So what happens is, now on the operating system, directly the application is not running. Now on the operating system, directly the application is not running. What is there is, on the operating system, you are running something else. This something else is called Docker engine. Absolutely correct. So what you do is, on the operating system, first you install Docker. Okay. Now what happens is, first on the operating system you install Docker. Okay. So you install Docker. This is the Docker engine. Perfect. Now what happens is, to this Docker engine, you give what? What do you give to the Docker engine? What do you think you will give to the Docker engine? To this Docker engine, these commands are written where? Where are these commands written? Docker file. Absolutely correct. You will give the Docker file to this Docker engine. Absolutely correct. Now when you will give the Docker file to this Docker engine will read the file and automatically set up the environment. For example, to set up the environment, it needs the application. It will automatically get the application from wherever. It will automatically put the application there. It will automatically download those files. Okay, file 1 is needed, file 2 is needed. It will automatically do what? It will automatically, for example, install the dependencies. JUnit is needed. Let us say Razorpay is needed. Okay, whatever dependencies are needed. Everything else, who is doing? Docker engine is doing. Is everyone clear with this? Absolutely correct, Pawan. So one prerequisite that has to happen is, now you have to ensure that Docker engine is installed. Now the only thing, earlier you manually on every machine had to install Java, had to install all the dependencies. You had to ensure the correct operating system. Now the only thing that you need to ensure on every machine is, what is installed? Docker engine. Absolutely correct. The only thing now that you need to ensure is to install the Docker engine. So what do you do? Now the work of a DevOps engineer is just simple. They will create a new server. Okay. Now on that particular new server, they will install Docker. They will install the Docker engine. Now after installing the Docker engine, what will they do? They will just give the Docker file. Give Docker file to engine, and that's it. Done. Everything else is ready. That's it. All set. Everything else will be getting done by the Docker engine. Docker engine will automatically get the dependencies. Docker engine will automatically do all of this work. It will automatically install correct operating system. Okay. It will automatically get dependencies. Okay. It will automatically execute the commands. All of the work that earlier you used to do manually. For example, all of this work that was there, right, which was manual, all of that work will be now automatically getting done by the Docker engine. That is the benefit that Docker gives. Okay. Cool. It will replace existing operating system? No. So what it does is, now on one Docker, you have a Docker engine. Can you install multiple Docker files? Can you give it multiple different files? Absolutely right. So one Docker file is for one application. Now if you want to run 5 applications, it will run 5. Okay. So what will happen is something like this will happen. Okay. This is your hardware. Okay. Now in this hardware, your base operating system will be there. Okay. So for example, you buy a server. On this particular server, let us say you install Ubuntu, which is our base operating system. Now after that, on this you will install Docker. Okay, Docker engine. Now on this Docker engine, you can install multiple files, do whatever you want to do. For example, with each file, you can have one application. So let us say you have 3 applications. You will have Docker file of application 1. Of application. Similarly, you will have Docker file of application 2. Similarly, you will have Docker file of application 3. Okay. File of application 3. Perfect. So 3 applications will be running. Now this application needs to have, let us say, Fedora operating system. This application needs to have, let us say, Ubuntu operating system, Ubuntu 22. This application needs to have Ubuntu 18. All of them will be working completely independent. Okay. What is Docker Engine? Current Docker Engine is just an application. That is what Docker is. Docker Engine is just like an operating system. Okay. Docker Engine is basically the brain, is basically the core of Docker. This is what is setting up all of the environment. This is what is automating everything. Automating everything. Okay. Good. I said, now let me ask you a question. Now, if all of the instructions on how to set up an application are present in the Docker file, if I just give that Docker file to you, in your computer as well, will the exact same application be set up? If I give a Docker file to you, in your machine as well, will the exact same file get set up? Absolutely right. That is the benefit. Okay, that is the benefit of what having a Docker is. If you have the Docker file, now across any machine, the environment will be exactly same, the things will be exactly same. Okay, perfect. If it is a Windows operating system or Ubuntu, then so Samir, again here, your base operating system can be Windows. Your base operating system can be Windows. Okay. Now you are running Docker Engine, you can run on Mac OS as well, on Ubuntu as well, on Windows as well. Okay, but what will be the operating system where the application will be running? That can only be Linux. Okay, is it clear? What if 2 applications are running? There's a question, what if 2 applications are having conflicting environment setting? What will Docker do? So Kapadia, if you see this, right, what is Docker doing is Docker is creating an isolated environment for each of them. Docker is creating an isolated environment for each of them. So technically for these applications, all of them are different computers. All of them are completely independent computers. So they will not even know that there is another application that is also running on the same machine. They will have no idea about them. Okay, so for example, if this application needs port 8080, it will be running here. Port 8080 of this virtual computer, so as to say. It will be running port 8080 of this virtual computer, so as to say. Is it clear? What is that you mentioned about Linux? So Manoj, the only thing that I mentioned was in these machines, right? When you are running application, here the operating system is restricted. Docker doesn't allow you to have Windows here. Okay? The base operating system can be Mac OS, Ubuntu, Windows, whatever operating system that supports Docker Engine. But the operating system that is going to be used by the application that has to be used, that has to be Linux. Okay? Yes, Mukesh. Base operating system can be whatever, Ubuntu, Mac, Windows, Linux, anything. Okay? So, perfect. Now, let us do one thing. Okay? Let us actually try to do a practical of this. Till now, we have just seen theoretical way. Let us try to actually do a practical of this and see if things work. Okay? Clear? So Docker is a virtual machine. Himanshu, it is like a virtual machine, but much more lighter. In fact, you can think of the difference between Docker versus virtual machine as very, very similar to the difference between a thread versus a process. Very, very similar to this. Okay? Yes, Rajat, because both of them are completely isolated. For these applications, they are 2 different machines. Okay? So now, let us actually see this in practice. Okay? Let us see this in practice, and then you will probably understand a bit more details about how to work. So, let me open my computer. There are 2 operating systems we could see on the drawing. Will it be lightweight? So, Kiran, again, yes, that is this operating system that is there. It is going to be just the minimal operating system that is needed for you to run the application. Okay? Just wait a few minutes, just see things in practice, and then you will understand it. Okay? So, just give me a moment. Perfect. Just 1 minute. I'm just setting up the machine. So, okay. Are you able to see my screen? Are you all able to see my screen? Perfect. Cool. So what I have is, here we have an application that we have already written. Okay, so this is a simple e-commerce application that we have written. Okay, and yeah, when I will be writing the code, I mean, okay, do whatever you want to do by writing this. Okay, what will you do? So what has blurrish? It should not be blur. Is it still blur? Acha, I get it. Just a moment. Is it now blur or now is it completely visible? Now it's clear, right? Super, perfect, cool. Now, what we have done is, here we have an application that we had written a few weeks ago, and using this application, we will be trying to demonstrate Docker to you. Okay, let me just, okay, I have already zoomed it a lot. Let me refresh.
Guys, don't worry. Naman is just joining in a minute or so. Yeah, he has joined right now.
I think it should be now completely fine, right?
It's perfectly visible, Naman, I believe.
Okay, super, cool, perfect, super. Now, this is an application that we already written. Let me actually send you the code of this. This is the code of this. Okay. Perfect. Okay. Now, what we have to do is, let us say we have to run this application on your machine. Okay. Let us say if Mudit has to run this application. How will Mudit run this application? Okay. There is a code. I have sent the code to all of you. If you had to run this application on your machine, what all did you have to do? What all did you have to do? What all did you have to do? Let us say without the knowledge that you had gained in this particular class. Without having gained the knowledge in this particular class, what would Mudit or what would you have to do? You would have to do all of these things yourself. You would have to first install Java. Then after installing the Java, you will see that, oh, my application needs Spring Boot. So you will need to install Spring Boot. After installing Spring Boot, you will realize that my application also needs a database. So what you will do is you will also install database. Okay, you will install MySQL, you will install those kind of stuff. And then only will you be able to do the code. Agreed? Perfect. Now, how to solve for this particular thing? The solution of this particular thing is, what is that black console? Where is this black console? Anyways, cool. Now, let us say, if you didn't have to do this work manually, who can help you do that? The thing that can help you prevent doing the manual work is Docker. Now, in Docker, see, once you will have to give the instructions. So see, if you want someone else to be able to do work on your behalf, you as a person have to give instructions at least. Do you agree with that? That if you don't even give instructions, how will you be able to do some work? Do you agree with that particular thing? Correct? Okay. So now, where will you give instructions in the case of Docker? Where will you give instruction in the case of Docker? In case of Docker, instead of writing a Google Doc where you give the steps, you create a file called Docker file. Perfect. So what I will do is, I will create a Docker file. So I will click here, new file, Docker file. So I've just created a Docker file. Docker file is a simple file with name as Docker file without any extension. Is that clear? Okay, so Docker file is just a simple text file, no extension, not .txt, no .doc, no .pdf. It is just a simple file whose name is Docker file. Okay, it's a simple file. No, it's a simple file. No language, nothing. It is just a simple file. Okay. Now, what you are doing in this particular file is, in this particular file, you write the set of instructions. You write the set of instructions that are needed to run this application on any computer. So if someone wants to run this application on any computer that has what? What is the expectation from that particular computer? Correct, Javelin, absolutely right. What is the only expectation that is there from any other computer? It should have the Docker engine, correct. If you want to run this particular thing on any computer that just has the base operating system, okay, how will you do that particular thing? That is what this Docker is. Okay. Now, for this particular thing, I will have to install at least Spring Boot. I will have to install Spring Boot. I will have to probably install Java. I will need to do all of this kind of thing. Okay. So, imagine if I had to manually write the Docker file from scratch. Will I do something like this? That probably first of all, install Ubuntu. Let's say Ubuntu 22. Okay. After installing Ubuntu 22, install, let us say, Java. after installing, and in Java also which version? Let's say Java 17. Okay, after installing Java, maybe what happens in a Java application is, see, typically when you download an application from internet in what format? Typically you download an application from internet in what format? In exe format, right? You download an exe file or you download a DMG file and then you try to run that on your machine. Okay. In Java, there is a jar file. So what you can do is in Java, if I just click here, I click on profiles, I click here and I will click on lifecycle and I will click on package. So what will Java do is, just wait a few seconds. There was a test case that failed. Just a moment, please. For now, let me ignore these test cases. Okay. Let me again click on package. So in Java, like for example, when you typically install anything, you get a .exe file or you get a .dmg file. If you have to share an application that is written in Java, there is a .jar file. So as soon as you did this, if you were able to read this, I'm not sure how many of you are able to read this properly. It will say something like this, building jar at this particular place. So what Java does is Java creates a .jar file. So at /target/product service .jar, there will be this file. If I go here in target folder, do you see a jar file is there? Are you all able to see this jar file? Right? Now this jar file you can run on any machine that has Java installed. Okay, this jar file you can technically run on any machine that has Java installed. So technically, what will be the series of steps? The series of steps will be something like this. Okay, it will be something like, if you go here, you install Ubuntu. After installing Ubuntu, you install Java. Then you run the jar file. Now what will happen is that this jar file may be running upon how jar file is created. Vishnu just, again, it's a very Java specific thing. That is not what the main purpose of session is. Today we are learning Docker Kubernetes. But anyways, you just go to this and you just double click on package. That's it. Okay, you will run the jar file. Okay, after running the jar file, you're done. Technically your application is done. Currently this series of steps has to be done manually. But if I ask my Docker file to do all of this, will my work be automated? Will Docker automatically set up the environment? Will Docker do all of those things? And will it automate my work? Absolutely correct. Okay, so let us try to get the Docker file to do this same thing. Okay, when I clone the repo, I didn't get the Docker file. Arey bhaiya Harisha, Docker file I created within the class. The repo has a code that I had before the class. Okay. So I just created a file. So you also can create this file, Docker file. Just right click and create a new file called Docker file. Is it clear? Now when you said Java is automatically provided, no such thing. Java is not automatically provided. Why will a machine come with Java installed? A machine at the end just comes with the operating system installed. Everything else you have to do yourself, right? Everything else you have to do yourself, okay? Super, perfect. Now, super. Spring Boot, so Samir, a good part about this jar file is this jar file automatically contains all of the Java related dependencies. Okay, but let us say if my application also depended upon some other file. For example, if my application also depended upon a file called /home/etc/desktop/abc.pdf, will I have to also ensure that this abc.pdf is created? Which is this ID? This IDE is IntelliJ IDEA Ultimate. Okay, this IDE name is IntelliJ IDEA Ultimate. By the way, I'm not sure how many of you know this, but every Scalar learner gets a free 2 years license to IntelliJ IDEA Ultimate. So if you enroll for Scalar, you get a complete 2-year license to IntelliJ IDEA Ultimate, which is a very premium IDE, which is probably the most popular IDE for Java development or for any kind of development for that matter, even used at companies like Google. Okay. So anyways, this is what the ID is. Okay, Docker file will be created only if Docker is installed on my system. Hey Ashish, it's just a simple file. It's just a simple file. On any machine where you can create a file, you can create a Docker file. Docker file at the end is just a file. It's just a simple file. Okay, any machine where you can create a file, you can create a Docker file. Okay, so now let us try to create a Docker file. Okay, let us try to create a Docker file. So what I will do is in fact, I will probably just rely upon a lot of Google search here. Just give me a moment. And also another advice, you don't need to. It's a good part that you don't need to rectify a lot of things if you are into software engineering or if you are into any kind of tech domains. You can always Google and you can always get an answer. So for example, how to write a Docker file for Spring Boot application. Docker file Spring Boot. Just Google that and you will get an article. Okay? Perfect. Cool. So there is this article. I mean, you don't even need to do ChatGPT. Typically, one good advice that I would like to inculcate in all of you as an engineer, as a techie. Initially, you may not know anything. Okay? But after learning, the eventual state should not be that you have rectified the syntax. The eventual state is you now know how you can figure out anything. You know what to search on Google. You know what query to put on Google. You know which article to click when Google gives you multiple articles. You know how to read the article and give the information out of it. Interviews don't understand that. Sohail, believe me, in one very harsh term, for any company where the interviewers don't understand that, don't join that company. That company is not going to give you the environment where you will grow. Any good company, for example, companies like Cred, Razorpay, etc., even allow you to go to internet, use ChatGPT, do whatever you have to do the machine coding notes. That's perfectly allowed. Okay. Why don't you use Docker Hub instead of Git? Anu, when you have to go to school, do you go to a club? I mean, to study, do you go to a club? No. Similarly, to party, do you go to school? No. Docker Hub has a different purpose. GitHub has a different purpose. So that is why the purpose that I had till now was to share the code. To share the code, you have GitHub. To share a Docker image, which we will learn about later, you have Docker Hub. So you have to go to the correct hub, depending upon what kind of thing you have to do. Clear? Super. Cool. Perfect. No other meaning. Anyways. Cool. Super. So what we have to do is, you have to now create a Docker file. You will create a Docker file that automates this particular thing. Okay. So here, if you read this particular article, it says something like this: from Eclipse Temurin 17 volume this R jar file. What is this? Okay, let me just copy this. Okay, let me just copy this particular thing and paste in my header. Okay. Let me go here. Let me paste this. Perfect. So now what is it doing? Let us try to understand basics of this. Okay. Cool. So let's try to understand basic basic things out of it. The basic thing is from. What is this particular from doing? See, either you will start from scratch. You start by setting up the operating system yourself. Okay. You say install let's say Ubuntu or install Linux. A good part is many people already have created a lot of what is called a Docker image or what is called a base thing. So for example, let me open Docker Hub. Just a moment. Perfect. So here what I have shown you is I am showing you hub.docker.com. Okay. If you go to this hub.docker.com, can you please denote step by step from scratch? Mohammed, don't worry. I will send an article to you for this particular thing. Okay. If you go to this particular place, let us just search Java. Okay. So what many people have done is many people have already created a image or created a base image upon which you can build. Like I mentioned earlier, don't reinvent the wheel. Stand on the shoulders of giants. If someone else has already done something, don't start from scratch. Imagine, there are two ways that you had. The very first way that you had was that, yes, I'm going to get to that. Yes, all of this is free of cost. Whatever we are learning, all of that is free of cost. Okay, cool. So, the very first way that you had was, Arun, I know that. Don't worry. I'm not taking this session for the first time. So, the very first way that you had was, you could have first installed Ubuntu. Okay. Cool. After installing Ubuntu, you installed Java. After installing Java, you had to set up Java as well, right? Typically, whenever you have a Linux environment, you have to set up anything that you install. You have to put it in path, etc. And after that, you have to download the code of application. Download code of application. After downloading the code of application, basically you will, let's say, make the jar file. After making the jar file, you will run the jar file. Okay? You will run the jar file. But now, let us say if someone already gives you a base environment which has all of these things. These things. So basically, they give you an environment that already has Java installed. Java already there. Which one will you prefer? For your use case, would you want to start from Ubuntu and then install Java, then set up all of this? Or would you prefer that, okay, Java already set up, so perfect, I already have an environment where Java is there, Java 17 is there, then I will just download the code of application. Download code of application. After downloading the code of application, I will just make the jar file and I will just run the jar file. Second option is going to be better. So the second is what we do. So typically what has happened is, if I go to hub.docker.com, if I go to this particular place, on this particular place, you will see a lot of things already there. Instead of starting from scratch, instead of directly starting from operating system, what you can do is you can start from a base image. What is this image? I will get to that. Okay. Array Sneha, we will learn how to create the images today. Don't worry. Okay. So let us say I search for OpenJDK. Okay. Now if I go here, now in this OpenJDK, there is Java 17. So if I just, or let us say Java 21, I just need Java 21. So if I go to tags, there is Java 21. Okay. Or search for tags 21. So there is, for example, let us say there is 21 JDK bullseye. Okay, perfect. Now, instead of directly starting from base, I would want to start from this JDK image. Okay. Now, behind the scenes, what do you think about this JDK image? The person who would have created this particular JDK image, they would have tried to start from the person who would have actually created a Docker file that automatically sets up the environment with JDK, etc. They would have started from maybe that person, the person who created this particular application, this particular environment where Java is already installed. They would have started from scratch, right? They would have started from scratch. That is why if you see here, one person started from Debian 11, then someone created this file out of that, then someone created this file out of that, then someone created this. In fact, I can show you the GitHub code of this. I think if I just go a bit back, I should be able to maybe see the GitHub code of that as well. Just give me a moment. Perfect. Docker library, OpenJDK. If I show you Dockerfile, I think where was that particular thing? So if I go here, bullseye. So if you see, the person who created this particular Docker file, how the JDK 11 was created, do you see they actually started from something called buildback deps, and what this buildback deps actually started from was Ubuntu. So this is technically how it happens. Anyways, the only thing that we have to care is, instead of starting from scratch, I will say get all of the code that is already there here, get all of the environment that is already set up in this image, and in the environment of this image add something else. Does that give a basic understanding? Does that give a very basic understanding that maybe rather than starting to set up my environment from scratch, get the environment that is already set up by this image, and after that add a few things to it. Is that clear? Cool. Now what I will do is, this image word is coming a lot. What we will do is, because this image is a very core concept of Docker, current coming there, Docker image, Docker container, all of those we are coming. Okay, perfect. But because this is a very important concept and we are also in the middle of the session, let us just take a small break. Let us just take a small 10-minute break. At 9:15 we will start, where we will start by learning about key Docker terms. So currently we are into this particular thing. We are Dockerizing our application, as well as we are learning key Docker terms. Why JDK? So when typically to run an application, you need the complete JDK. Okay? Perfect. What if that image is broken after some time? Then your code will not run. I mean, the answer to those what ifs is very simple. It will fail. That's it. For example, if someone asks you that, okay, give me this particular gift by 50th, on my 50th birthday, do you ask them that, okay, what if you die before the 50th birthday? I mean, obviously, if you die, you don't give them anything, right? That's how simple it is. Okay? Anyways, what we'll do is we'll take a break till 9:15, I think. We'll take a break till 9:15. But till the time we take a break, let me also probably spend some time to briefly talk about how we cover all of these things. Okay. Question is, do you think in today's 3 hours, is it enough to cover everything of Docker and Kubernetes? Obviously no. To give you an idea, Docker, this session is just a high-level fundamental of Docker and Kubernetes. Many of you, in fact, are asking questions, how does this happen in Docker? How does that happen in Kubernetes? That is not what we are going to discuss today. So in case you have that expectation, sorry, this session is not the correct session for this. Okay, perfect. In fact, to give you an idea, in Docker, Kubernetes, or many other Docker technologies for that particular matter, there are a lot of certifications. In fact, certifications also have a lot of levels. There are beginner level certifications, there are intermediate level certifications, there are advanced level certifications. Okay. For example, in Kubernetes, there is CKAD. Okay. In Docker, there is Docker certification, right? Now, the more advanced level certification you give, the more detail you cover this in. For example, at Scalar, we have a Scalar DevOps program. Okay, in Scalar DevOps program, the goal that we have is that over a 12 to 16 month program, Scalar DevOps program is actually a detailed, very comprehensive 12-month to a 16-month program where we cover all of the things that are needed for a DevOps engineer, for an SRE, for a platform engineer in complete depth, to the depth that is expected from a person who can achieve an advanced level certificate. Okay, there we cover Docker, Kubernetes, and other tools in 3 months. We take 3 months to cover all of these things in complete depth, up to an advanced level certificate. For example, for Kubernetes, up to the level of a CKAD. There, we actually don't just cover on Docker and Kubernetes. As I mentioned earlier, there are a lot of DevOps engineers actually start failing in their career just because of being a lot of into tools. They just want to learn that, okay, how do we do this? How do we do that? How do we do that? Instead of learning why do we need something, instead of learning the art of figuring things out. In these 3 months, we actually build that particular art. We build that particular vibe. We build the need of each of those things. So in this particular program, because it is highly comprehensive, it prepares you for all of the roles like DevOps engineer, cloud architect, cloud engineer, SRE, infrastructure engineer, platform engineer, all of those things. In this particular course, we teach actually all of the things that are expected from any company, be it a very simple company to be a very top company, for DevOps roles. For example, we cover things like data structures and algorithms. We cover Python. We cover Linux and computer systems fundamentals. We cover SQL. After that, we cover tools. What tools? We cover tools like Docker, we cover tools like Kubernetes, we cover tools like Jenkins, we cover tools like Prometheus, Grafana, all of those things. Then we cover AWS. Then some key things, we cover system design. After covering system design, we cover advanced data structures and algorithms as well. This ensures that many DevOps engineers who actually want to end up for roles like SRE, infrastructure roles, platform engineer roles, all of those roles are they also prepared for. Okay, so it's a Scalar DevOps program. We'll talk more about that. In fact, you can see a lot of details about the Scalar DevOps program here as well. There is a link that I'm sending in the chat. Okay, you can go to this particular link and you can see a lot more details about the Scalar DevOps program there. But this is the most comprehensive cloud computing SRE program that exists in the industry as of today. We cover Python, we cover data structure algorithms, we cover Linux, we cover DevOps tools, we cover AWS. And a key part is that we cover all of them to the depth that is needed to achieve the advanced level certificate in the corresponding domain. Okay, cool. Now, how we are different from anyone else. When we cover these things, we don't just cover the theory part of it, or we don't just do the practical. We have real hands-on sandbox environments where you will get a real simulation of how to do the things in your day-to-day job. For example, in very good companies, typically the DevOps interviews are not case study based. You're given a sandbox environment where there is a bug. You have to try to find out why this particular bug exists, why there is a particular problem statement that is there. Okay, you have to run some commands, you have to see the logs, you have to do all of that in the machine, and then try to tell the root cause of it. All of those are the kind of assignments we do in this particular program. We also have teaching assistant support. We also have one-on-one mentorship as well as job placement support. Okay. Now, many of you may have a lot more questions about Scalar. I think we have a break time, so I would not want you to take much more time. But what I will ask Swan to do is, Swan will launch a particular poll in the chat. Okay. If you have any question about the Scalar DevOps program, if you are curious about this program, if you want to understand this in much more detail, do say a yes to this particular poll. All of the things with respect to what our USPs are, how is this curriculum structured, who are our instructors. By the way, our instructors come from top companies, having worked at SRE roles, DevOps roles, it's a lot amount of years. Okay, having the highest amount of salaries that you can probably expect in the DevOps domain. So if you have any questions with respect to the Scalar DevOps program, if you're curious about this thing, do say a yes in the poll that is running on your screen right now. Our team will be more than happy to explain any questions that you may have about that, talk about the curriculum in depth, talk about the mentorship, talk about the teaching assistant support, all of those things. Okay? So yeah, the poll is running on in the chat. I will hand over to Swan for now to take it from here till the time we have a break. Okay? Swan, over to you.
Thank you so much, Naman. Also, in the meanwhile, if you can also stop sharing your screen so that I can just quickly share some of our daily success story with our learners as well. So guys, the poll is live, just like Naman mentioned. So click on the particular option like it's a yes